Well, hey everyone, I'm Nick Pettit, and I'm here with Armen Pischdotchian, and he is an academic tech mentor at IBM Watson. How are you doing today?
Nick, what a pleasure. Thank you. Doing great.
Cool. Well, first, I just want to ask you, what is Watson?
Oh, great question to start off with. Let me bring us back to 2011. That's when we had the Jeopardy game. And interesting story behind that, Sony Corporation, that happens to own the Jeopardy game, the American quiz show, knew about Watson. They approached us and they said, so you say that you have a system that can actually beat these two Jeopardy champions, Brad Rutter, Ken Jennings? We said, yes, we do. We have a high confidence. It's never a yes or no with probabilistic system. We have a high confidence that we can beat these two champions. They said, fine. And we set up the stage at our conference room, and the rest is history.
Well, so you did Jeopardy, and then what happened from there?
And so Watson eventually was born. It became productized. It became a product.
Right.
I am always reminded of our CEO, Ginny Rometty, that she has termed the coin Augmented Intelligence. The idea in here is that Watson is helping people and machines work together to create knowledge from data that enhances human expertise. Watson isn't here to supplant and remove jobs. It's here merely as a second opinion to the doctor. In fact, I'm reminded of an example, a personal example that I witnessed. On the way here from the airport, we were, the taxi that I was in was cut off by this giant truck in front of us. And we could see the reason was because the truck was trying to avoid another car that clearly you could tell the driver was texting and driving.
Right.
And so he had to swerve in front of our lane.
Right.
The taxi driver said to me, Armen, you know, my brother-in-law is a truck driver. And frankly, truck drivers are some of the best drivers, period. They have a preference to drive at night, but they can't. They're mandated to sleep. They have to log that they have slept.
Right.
So this puts them in traffic during the rush hours. So I'm thinking to myself, how great would it be if this autonomous vessel did the driving on its own across country, allowed the truck driver to sleep. When he woke up, as it got closer to the destination, then he would open up the laptop and do inventory. Nobody's job has gone away, but the mundane, the arduous has been taken away. So now we can focus on what is meaningful.
Right. So you call this augmented intelligence. How do you see this being used in the real world?
I think one place that it's becoming prevalent is in the field of data science. Let me take a step back in here. If you note the data, 85% of it is unstructured. These are tweets, emails, MRIs, CAT scans, audio conversations, videos. That is where I want to gain my insight, my knowledge. Not so much from structured data that happens to happily reside in a table that I can call it with a SQL call from a table or a column. Now, structured data, transactional data also has its importance. I think where these two come together is in the field of data science.
So what it sounds like is that Watson is able to elevate the level of questions that you can ask of this data.
Yes, let me add to that. It is accurate. It is accurate. In fact, some of the services that we will have in this course, the conversation and discovery service, lend themselves to that insight extraction. I always like to think of the conversation service, the chatbot that we will build, about imagine all the things that you know that you don't know. Well, wonderful. We can then use a conversation service to find, at least you know what it is that you don't know. Now think about all the things that you don't even know you don't know. Now that's insight. I think that is where the discovery service, especially if it's connected to the conversation service, We will explore that in the course as we move forward. That's where insights are extracted, where the understanding and the knowledge is extracted from information.
So tell me about the future. I mean, you're talking about the present and what we can do right now, but where is this all going?
Currently, there are three major calibers of AI. And there is artificial narrow intelligence, ANI. That's where we are today. There are the most fantastic technologies at work, whether it is self-driving cars or the work done by Amazon, Twitter, Facebook, IBM, Google. We're at the artificial narrow intelligence. To have a better understanding of where we are now, let me take a moment and talk about where we may find ourselves tomorrow. Artificial general intelligence, AGI. This is where the machine is equal and perhaps millions of times further ahead than a human. Case in point, an example. Carnegie Mellon University, CMU, robotics department. I had the pleasure of being invited there for a lecture. And when you walk into CMU's robotics division, you're greeted by a robot. Now, this is not a humanoid robot.
Right.
Cameras, laptop, and a pod, and track wheels. I had registered in Numi. Hello, Armen, welcome. What a refreshing greeting that is, Dan. Can I help you? Since my bio was available, so it had face recognition, it clearly knew it was me. And it takes a look at the appointment that I may have. And I was told later that if I have arrived early enough, it would suggest if I want to go to the cafeteria for refreshments. In this case, I happened to be just in time to get to my meeting. And so I asked the robot, can you take me to John's office? The robot said, sure, Armen, follow me. And so I followed the robot. It said on the screen, in 20 feet, we'll turn left, in 30 feet, we'll turn right. Fine. I did as it did. As it went by the elevators, one of those software engineer types, neural network software engineer types, kicked a chair in front of the robot. It saw. It seized the chair. It stopped. Laser, LIDAR, everything. I think that's the easy technology, that part. I stopped as well, looked at the software engineer with somewhat of a puzzled face. And it went around the chair, and I went around the chair, and finally we got to John's office. John asked the robot two questions, two very difficult questions for any machine. What happened at the elevator? Why were you late? The system is gaining an awareness of its surrounding, of its environment. It's gaining experience. We're doing similar work at our Almaden research facilities in California, where we call it Embodied Cognition. IBM fellow Grady Booch and his colleagues are working on exactly that. Systems that gain experience. And this isn't memory. That brings me to artificial superintelligence. I think one example would suffice to say, consider this. If I ask Watson today, Watson, tell me about neural networks, Watson would say, I'm sorry, Armen, I don't know about neural networks. Perhaps you can teach me. Fine, we'll ingest a PDF or crawl the web and he will learn. As opposed to the day after tomorrow, if I ask Watson, Watson, tell me about artificial networks. And Watson would say something more like this. I'm sorry, Armen, I know that I don't know about artificial neural networks. Perhaps you can teach me. That's self-awareness. And suppose you might ask, when is this going to come to bear? Ray Kurzweil, Singularity University, is currently at Google, a futurist, depicts that AGI would be somewhere around 2040 at our doorstep. And he thinks ASI would be somewhere around 2060 for systems to have that awareness.
So data science is rapidly emerging as one of the most important career paths of the future. What does a data scientist need to know?
Perfect question. Absolutely, absolutely. I'm reminded of Professor Morteza Baidar from Ryerson College in Canada via University of Toronto. I think he summarized it perfectly. He said that curiosity is the beginning stepping stone for a data scientist. Is 2 bedrooms more valuable, or is having more land more valuable? Just that sense of curiosity to question everything in their surroundings. Knowledge of various machine learning methods helps. Although he also is quick to point out that data science is a team sport. One doesn't need to be master of all. You can pass the baton from specialty to specialty. But it helps for a data scientist to be versed in some languages that data scientists use. Python, especially working with Jupyter notebooks, R, Scala, depending on various applications that they want to. For example, R lends itself very well to heavily statistical work, regression and so forth. Python is a bit more of a general language, and it's a bit easier to master. And it also lends itself well to machine learning models. And data scientists would take the data that they have collected and they would run it through various models to try and see what sort of an accuracy each model gives. They will try things such as support vector machines. They may try random forest trees, Bayesian inferences. I call these brute statistics. At the core, logistical regression is the engine that's running them. If their data happens to be multimodal, a lot of variables, they would perhaps try neural networks. With images, it lends itself that much more readily to convolutional neural networks. CNNs, of course, have their own drawback with the diminishing gradient problem. Imagine when you take a copy of a paper, and then you take the copy of that copy, and then a copy of that copy. Eventually, it starts to become not so clear. Perhaps by the 10th copy, you can't even read what it is. That somewhat is akin to the diminishing gradient. The first layers of a convolutional neural network train much slower than the latter layers. The first layers might just look for edges. They would say that my chin is an edge. It doesn't know it's a chin. That's an edge. A layer later, it would find 2 other edges that always appear in the 2 sides of this one edge. So those are the layers that learn slower. And then it perhaps lends to a little bit more inaccuracies. But then the other layers take that, inherit it. So they might find that perhaps they want to use another method called recursive neural networks, recurrent or recursive. It actually treats each layer as though that's an input node. So it starts all over freshly. It has a feedback mechanism. They might even want to try with other algorithms, long short-term memory, LTSM. We're working with that quite a bit at IBM to help gain the system and experience. And of course, a data scientist, then they may pass the baton, or Professor Haidar stresses that the visualization, the explanation of what it is that they have collected, what it is that they have built patterns out of. After all, machine learning is a fancy way of saying, build me patterns. And that visualization is what they then need to pass on to the C-level executives or to their end users to impact the decision that they need to make.
Very cool stuff. So you mentioned that we're going from artificial narrow intelligence to artificial general intelligence and then superintelligence. What are the steps along the way between each one of those milestones?
Oh, wonderful question. Let's take them. Let's go a little bit further back. In the beginning, and I want to quote Pedro Domingos in his wonderful book, The Master Algorithm. He depicts stages. Stage one is calculations. That was perhaps in the beginning of the 20th century. Let's just think about it. Even prior to that, mathematics. That led to stage two, methods and algorithms. Think of C++, object-oriented programming. Sure. That led itself to stage three, analysis, regression, tried and tested. It led itself then to stage four, supervised learning or optimization. Very much a machine learning methodology used nowadays. Supervised learning has the benefit of you not needing to have so much data, but it is arduous because you have to label that data. Oftentimes it leads to greater accuracies than your other methods of learning. A little bit more challenging is unsupervised learning. That's problem solving. Think of the Amazon Recommender app or Netflix, that the recommender engines are unsupervised learning. I may buy a certain book, and in the bottom it says others also purchased books as such. Now, Amazon doesn't know my habits, what books I like, or so forth, but it has a lot of data of folks who purchased this particular book have also purchased these other books. Perhaps one of those might be something that I'm looking for. In unsupervised learning, data is clustered, but it's not labeled. One might go and label a few, and you could then call that semi-supervised learning, and that itself is also another approach. The one that really gets me is stage 6. There are 7 stages, really. Stage 6, we call that unsupervised asking, rhetorical learning. What do I mean by that? Let me give you an example. Consider this. Let's say I get on my phone and I say, Watson, my muscles are hurting. My joints are sore. My nose is clogged. What's wrong with me? So Watson goes in the back and does its data analysis. And my phone is, the browser is geo-sensitive. So it knows, for example, that I happen to be in Massachusetts. It does a spatial analysis. It does a temporal analysis. It finds out that it is October. It looks at NOAA, National Oceanic Atmospheric Association, and finds out that it hasn't rained in a while, and the pollen count is quite high. It comes back and asks me a question. Now, this isn't something you put in a chatbot. This is a rhetorical question. Do you have fever? I say, no, I don't. Negation is huge. It's a big algorithm. No, I don't have a fever. It goes back, takes another look at the data that is collected, comes back and says, I have 89%, I'm 89% positive that you have allergies, 4% positive that you have the flu. And you can imagine from there, well, what should I take for my allergies? You might recommend a certain drug off the shelf. I don't take any drugs at all, of any kind. Then you might say, why don't you try the local honey? That leads us to stage 7, as you were alluding to it, and that's the notion of unsupervised action, doing. We're not there yet. That would be artificial superintelligence. It's an unbounded action. Unbounded, it's not stuck between a 0 and a 1 in a table that you can, in a graph. Well, that's when robots make their own decisions, frankly. They have a community and they elect a leader.
So what will life be like when we just have this general artificial intelligence everywhere, or even a superintelligence?
Yeah, great question. What would perhaps I'll take a smaller bite, perhaps a more immediate impact of this, I think it would be as such. We've all heard of APIs. An API is really a RESTful method, application programming interface, for various services to interact with one another. The notion behind that is a URL, username, and password, or an API key. That's how you get from this room, where we do conversation, to the next room where discovery is taking place. I'm thinking that the next would be not APIs, but something called natural language interface. Bots will be communicating with one another. Frankly, they would be talking to one another. A service, not an API, but a brokeraged bot that happens to be the restaurant will be talking with the weather, will be talking with the golf course and advising me that I should leave the golf course soon because the weather is about to change and the restaurant's going to get booked real fast. I think another approach might be move over apps. Here comes bots. The notion of us downloading apps on our telephone, I think the days are numbered. Pretty soon, I would just look at my phone and I would talk to it. I'll say, get me a car. I need to get to Charlie's restaurant and tell me what's the special. Oh, by the way, is that the rain moving in tonight or later on? I don't need to download anything for this. I want the systems in the background to do the brokerage on their own and give me the information that I want. Blockchain technology, it's here already, very much so. I'll give you an example of a blockchain technology that I think might work well in a handful of years from now. Your fridge. The milk has gotten down to its lower threshold level. So a KPI, key performance indicator, has triggered a smart contract. That smart contract is well encrypted by blockchain technology. Apple Pay or Amazon Pay automatically does the transaction. The drone drops off the milk in the front lawn. The robot in the house goes, picks up the milk and brings it and puts it in an exact location at the fridge to restock the refrigerator. This entire thing really is a possibility of blockchain technologies and what it can do. Nanobots, I think, may be coming our way sooner than we think. It's quite plausible that I think in my lifetime I will have nanobots in my bloodstreams, checking the salt, the sugar, notifying me on my wearable device. Might be clothing, if not a watch. That Armen, stay off the salt and the sugar. Perhaps if a certain outlier is detected, it might automatically notify my doctor. I could get a call from my doctor and says, Armen, I've noticed that your ankles are swelling. You know that has something to do with cardiovascular issues. I might say, yeah, I thought my shoes were kind of tight. Why don't you come in tomorrow, Armen? And of course, the world of embodied cognition that we're working with at Almaden Research Laboratories. Embodied cognition is where systems now have an awareness of their surrounding. They gain experience. Some of the algorithms we used, LSTM, long short-term memory, go towards helping in bringing that feedback loop into the system, allowing it to understand that stairs hurt if I go and fall past it. And humans do not like it when I do this. It's experience is not the same as memory. And the sense of embodied cognition will give that to AI systems.
That's a world I'm looking forward to living in. Well, Armen, thank you so much for being here today. We really appreciate it.
My pleasure, Nick. Thank you so much.